Good afternoon. Welcome to session 3 of track 2. This is Paul Veeneman and Joe Weiss in their talk on OT security when the cure is worse than the disease. Gentlemen?
Thank you. Thank you very much. So, when I put this slide deck together, I didn't think about the visually challenged, such as myself, trying to read this type, so I apologize. As you said, my name is Paul Veeneman, OT/IT Risk and Security Management. I do a lot in critical infrastructure, mostly freight, rail, and rail security. However, working with water, wastewater, oil, gas, energy, renewables, do some work in that area as well. I'm a little bit more of let's say a quick show of hands. How many people are in IT? How many people are a process control engineer? Okay, so typically what I do, and you'll get a bit of both worlds here, is I'm on the OT for IT side. Sat on the IT security side and then made that transition over. So that's why you see I've got certifications and then also I sit on the boards of the International System Security Association as well as ISA, and I work with ISA in the workforce development. I would not be here today if it wasn't for the next person I'll allow to introduce himself, colleague, friend, and my mentor, Joe Weiss.
Thanks. Thank you. The last time I was here in Houston at the George Brown Convention Center was, believe it or not, 9/11. Why? Because ISA had their big international exposition in Houston, and everything was here at George Brown. And on 9/10, remember this is 2001, we had sessions ongoing on control system cybersecurity. And it was exactly opposite of everything you just saw. Every single person there was an engineer. The idea of having IT wanting to wander into a control system meeting was heresy, okay? Gee, things have changed, haven't they? And oh, by the way, it took me about 3 or 4 days to get home just to get a rental car to get out of Houston. People have no idea what all happened, the results of what happened with 9/11, because there were no planes flying, there were no trains. It took 2 or 3 days to even get a rental car company on the line. Not exactly, and by the way, when I was here, we had a session, and one of the people there with me was from NIST, actually a joint NIST-NSA assignment. But it's almost exactly opposite of everything you see here today. And it's not for the better at all. What I wanted to do is talk about 4 things that have happened over the past 2 weeks and give you a better idea of exactly what is really going on and how almost none of it, when it's control system issues, is ever identified as being cyber. Because you talk to all of these quote-unquote OT cyber people, and yes, they recognize Stuxnet and German steel mill and whatever, and it kind of goes. They also will tell you about Oldsmar, the water plant in Florida that was quote-unquote hacked. It was not hacked, it was operator error. That was not a cyber attack. And yet all of EPA's cybersecurity requirements are based on a user error. Isn't that an interesting problem? None of it has to do with the actual control systems. Because of Colonial Pipeline, TSA's pipeline cybersecurity requirements have absolutely nothing whatsoever to do with a pipeline rupture. Nothing. It's basically all about the networks. only there's a difference between what network people call a pipeline and what engineers call a pipeline. That got lost in translation. So I want to also counterplay what happened yesterday, I guess, with Arkansas City and Kansas. You had a ransomware attack. And the water treatment facility basically ended up putting itself in manual. Was there any problem? No. But it made the news, and everybody knows it was a cyber attack, okay? I put out a blog. In fact, before I even go through to there, people are aware of the CrowdStrike fiasco. I mean, this was cybersecurity software causing a shutdown of all of these systems. What's the definition of a cyber incident? You know, it's electronic communications that affects CIRA. That couldn't be more of a cyber incident. But you had people claiming that wasn't a cyber incident. Why? It wasn't Russia, Iran, or China hacking a network. Therefore, it didn't count. Now, what just happened last week, I'm sure people are well aware that a whole bunch of people got maimed and killed when pagers and walkie-talkies, and by the way, if you believe the Beirut newspaper, solar systems blew up, okay? Well, what people are doing is saying it was supply chain. Well, they're right. It's like the Miller Lite commercial, you know, supply chain, cyber. Because the issue there was, were explosives implanted in the devices? Yes. But were clocks or counters or anything else implanted in order to, quote unquote, allow them to go off on their own? No. What caused all of that to happen? Remotely actuating those devices. What more is a cyber attack than remotely actuating devices and affecting availability, like people dying or limbs going out all over or things exploding? Yet when I put the blog out, I had people coming back saying, well, that wasn't a cyber attack. What was it? You know, it was different because it was a combination of a supply chain attack and a cyber attack. But make no mistake, it was a kinetic cyber attack. None of which you're hearing about here, the word kinetic, which is the only reason control system engineers care. Things blowing up and people getting hurt. And by the way, in general, it will not come from the networks. It will come because you get to devices. The second thing I wanted to bring up is an article that came out on Friday. Does everybody here believe that Stuxnet was a cyber attack? I mean, it's kind of whatever. Is there anybody who doesn't believe Stuxnet wasn't a cyber attack? Okay. Well, what was one of the keys in Stuxnet? It was the man-in-the-middle attack to send misleading information to the operator that everything was still good, okay? On Friday, it was announced that 144,500 Ford Mavericks were being recalled. Why? Because it turns out there was a software and memory problem with the backup cameras. And what it was doing is, instead of having the cameras go dark, the cameras replayed past events. I just described Stuxnet. How many of you people heard about it or even thought for a second that could be cyber related? I saw Gene Spafford after his presentation mentioned it. He just looked at me. That's 144,500 vehicles from 2022 to 2024. Why this belongs here? Cure worse than the disease? Why did they put the cameras? Because people didn't like backing up on their own. So they put the cameras in, and what are they not doing? They're not turning their head to see what's behind me. So now you had this problem that the backup cameras were replaying previous events. Who's turning their heads? This is a real problem. Whoever thought about bringing that up in a cyber conference? It has nothing to do with internet protocol networks. One other thing I want to bring up, and the last will be a paper I just put out. But I'm on a committee called ISA 8409. It is the integration of process safety and cybersecurity. And by the way, there's nobody there from the electric industry, water, or anything else. It's almost all oil, gas, okay, and chemicals. That's a damning statement in and of itself. But the point there was, I asked a question after all of this time, what's remote access? How many people think they know what remote access is? I mean, it sounds like a crazy statement. You normally think, hey, I got a piece of equipment here and I got a maintenance vendor or somebody else, a city, state, or country away. Remote access also happens to be you're in a zone in a plant, and in another zone in the plant, somebody wants access to that equipment or that information. That's remote access too. Nobody's thought about that. I mean, it's crazy. I'm bringing it up literally last Friday. And it was like, we had to rethink and figure out how in the world we're going to define it. The last is, again, this is kind of a, whatever you want to call it, but Sam Houston State University had me write a paper, and it was published yesterday. And the paper was, who should be in charge of control system cybersecurity? And I will tell you who should not, and that's the CISO. The CISO doesn't own a single piece of equipment anywhere. They don't own a pump, a valve, a transformer, a turbine, anything. Why in the world is that person making judgments on equipment they know nothing about? And the reason, again, why am I bringing this up? We're going to be talking about the cure is worse than the disease. And I've got cases galore where IT or OT or the network people have caused as much damage, sometimes more, than a hacker did. Because they have no idea what and how and what the constraints are on the operation of our equipment. And yet, they're the ones in charge. And what you will see, like you see here, I think there was one person that raised their hand saying they were from process control. I remember, and I'll leave this, like I say last time, I was on a CISA Region 10 webinar. Region 10 is Idaho, Washington, Oregon, and Alaska. And one of the people whose CISA used to be the NERC-CIP coordinator at the utility that person was at. And I asked a simple question. How many times did an electrical engineer ever attend a NERC-CIP meeting? The answer was once. That person was there for 5 minutes and left because there was nothing going on that had anything to do with that person's job. Now, what does that tell you about the value of NERC-CIP? And I hear all of these people who are here because they're compliance types. They're certainly not operations or maintenance types. So anyways, this is my lead in to the cure is worse than the disease. Paul?
Thank you, Joe. Thank you. All right. So we'll get started off. So there's a bit of a medical motif, as you can see, right? So I tried to make it interesting, at least better than just clear the deck and give you bullet points. So symptoms, antidotes, and cures. So de facto methods of protecting are leading towards unintended consequences. So this will dovetail into some of what Joe was talking about, right? Where our natural practices, our methodologies, and our tendencies actually have unintended outcomes. We're trying to do good, but we end up taking a few steps back, 1 step forward, 2 steps back. We start down in at the bottom there of the thermometer. So 1990, AT&T long lines, there was a system update. So an engineer is making an update, and it was faulty in terms of software installed on the number 4 ESS toll tandems, took the entire long-distance network down. I don't know if anybody remembers that. I was actually graduating from high school at the time. So 2010, which is interesting when we consider CrowdStrike in 2024. 2010, McAfee releases a flawed update, a signature to the antivirus. Anyone remember that one in 2010? There you go. Well, yeah, so, see, I buried the lead. So the CTO of McAfee at the time was George Kurtz, right? And then we can see there in 2024, he's the CEO of CrowdStrike. In 2020, so SolarWinds, which is a little different, right? But it's still updates, right? It's updates that had malware that was intended to be compromised. Can anyone tell me the government institution, the one agency that was not affected by SolarWinds? What's that? Nope, not FEMA. No. They asked for stuff on April 15th. IRS. Does anybody know why? Probably not, because we didn't know who it was. So they had their firewalls, whether it was intended or unintended, they had their firewalls dialed down to only, and it's, how many people have heard the term least permission, least privilege? It was only systems that needed to access the internet over IP networks and IP protocols, as Joe was referencing, and only what they needed to talk to on the internet. That's a lot of work. It's a lot of work. But it gets back to assets. Know your assets, know your systems, and be able to assess the risk. Because a lot of what we see here leading up to CrowdStrike is cybersecurity is the output, not the input. And I know I'm saying that at a Houston security conference where we have a lot of vendors, and I do appreciate their sponsorship and everything they're doing for this event. But a lot of what they're selling is happening on the input. We are buying a stack of products, and we're putting them in because we're getting a false sense of security in the check boxes that we're checking. Are we truly doing the asset management and the assessment, and then getting to the risk management, and then determining what the risk treatment is? And that gets us into each instance is an intended cure, but the system of automated process is an antidote led to process operations. These aren't control system problems, but affect the control system. Okay? So we take a look at patient analysis. And here we have our doctor, right? And a lot of times it's us, right? It's the cybersecurity practitioners. And as Joe is referencing, typically on the enterprise IT side, because we're working on the security side to be able to strengthen the resilience of these systems. And resilience comes in a lot of flavors. Here we're looking at, these are pretty typical. Network segmentation, firewalls, protocols, all of these things. These remedies have been traits of normal success. Normal success being very mature processes in the enterprise IT. But not as well known on the OT side, right? You would implement, maintain, train these aspects, increase knowledge, continuous improvement, but, there's always a but, and now we see a very unhappy patient. This could be the type of impact that when the doctor prescribes something to you and doesn't know his asset, doesn't know you very well, and prescribes something that you have a slight allergic reaction to, okay? OT personnel are not always involved when the security is prescribed. As Joe was talking about, the difference between a CISO and an ops manager, who should be in charge. And on the process control side, or in the OT world, we do have process owners, right? And we have process operators. And we have owners, stewards, custodians in most cybersecurity frameworks as well. But it's increasingly important on the OT side because these are the individuals, as Joe referenced, they know those systems, they know the processes, and they know the equipment. Dependencies are overlooked due to lack of controller process knowledge. So this is where we're trying to build that bridge, get a common vernacular, and help people understand when you walk as an IT practitioner and you walk into a process control environment and the ops people look at you, what are you breaking today? You can have the back end, you can have the understanding of when the cure is worse than the disease. And you can also understand and get to know what is the asset, what is the equipment, and what is it truly trying to do on the network and where does it need to communicate. And also understanding there's far more below the network as well. It's kind of like the proverbial iceberg, right? And if you're wondering, you can follow Joe or go out to Control Global, the Unfettered blog, and he is a staunch advocate for understanding sensor data. As he was talking about the rear cameras, getting incorrect information causes you to make an incorrect decision. There's two things as IT practitioners that you'll want to know when you're talking to OT folks. Loss of view, which is inaccurate information or no information, and then loss of control, which is where safety starts to hit, okay? And then IT-centric solutions can have a negative outcome. So when in doubt, get a second opinion, right? So let's take a look at some of these security practices. The IT-centric side, if I'm going to have segmentation, I'm going to have VLAN, subnets, routed boundaries, et cetera. But do I need those in the OT space? Right? So in OT networks, how much complexity do you want? Very little, okay? OT systems are built for speed, and they're built for, and it's open architecture, so there's no authentication, there's no encryption, but they're built for speed and uptime and availability. Now you can have leading up to, let's say, your ICS firewall, leading up to that on the enterprise side, you can have that complexity. But once you step across that barrier and you're into the OT network, you want to be built for speed and optimization and efficiency. And then be able to get that information out. Industry 4.0, 5.0, right? We need to securely get that information out and figure out how to do it securely. And then have the business on the enterprise side, be able to take information that came out of a local historian, maybe through a data diode, right? And be able to use that. Firewalls, gets back to the IRS. Understand your equipment, what it's communicating on the network, what are the protocols, what are the applications, the services that it absolutely needs, and what does it need to communicate on the outside with? And then lock that all down. And I know what I'm asking when I say that, because it's a ton of work. It's hard, but it's usually 80% on front end, 20% on back end, right? And in working with your OT counterparts, you know, OT for IT, working with your OT counterparts and understanding the assets and the equipment that they have and how they communicate, because legacy and restriction of time-critical data can cause a negative impact in the process, especially manufacturing, where it's eaches, right? We're creating things and running them through at a clip of hundreds per hour, right? Speed is essential. Penetration testing. Has anybody ever turned loose a scanner in an OT network? How'd that turn out? There you go. Yep. So as Joe will tell you, so a PLC or programmable logical controller, HMIs, RTUs, they generally don't have a full stack, right? So they don't have full IP stack. They also don't have what we would typically, I mean, they have a Mac chip, but you can overrun the buffers pretty fast because they're built for speed and optimization, right? Low latency, and they're only doing, have you ever seen OT traffic, like DNP3, Modbus, TCP? Lots of data, very small footprint, right? So we always want to be cognitive of what we're doing inside there, especially in penetration testing. It's great to get the pen test and be able to strap that as evidence to your compliance audit for your CISO group, but understanding what that does. And asset managers are the same way too. Make sure you have an asset management system that is specifically built for the OT environment. I always tell my daughter this when she started out her career, be comfortable with being uncomfortable. Ask your software solution providers. If it's an asset management system in an OT network, what is it doing and how is it performing? What is it querying? Is it just banging away with pings to see if something's there and then ripping through 10,024 protocols. Let's see what responds. That's not going to get it done. Ask them if they've dialed it down to the protocols, or you can select the protocols, such as Modbus TCP or DMP3, Profinet, or Ethernet IP. If you got Rockwell and Bride. And then, as we said, network managed. So most legacy and current control systems not built to handle active inquiry, right? As I was saying before, I was probably skipping ahead. Encryption and authentication, right? It's an open architecture. So the data and control system comes and goes within milliseconds, but rarely is it confidential. What are we securing? Understand our data footprint. What's important? What's not important? You know, Joe has said this time and time again, is that the information inside OT systems, it's like the immediate history. That's already happened. We're into the next second or the next millisecond, okay? And in passwords and authentication, we've had conversations about this, 10 ways from Sunday. And Joe has stories about in nuclear, where you could have 3 or 4 different groups servicing control systems, right? How many people are with a municipality or a state? Anybody? How many work with water or wastewater systems? Okay. A lot of times it's an engineering service provider, right? So you've got a third-party engineering group that actually does the design, bid, build, and then the maintenance after the fact of the control systems. And then how do I have them plus the local operators? Who's going to have all the passwords to a system when it goes down? Or in the case of your incident response, and some of the best incident response, I know we've got Jonathan from Dragos here, so Leslie Carhart, probably one of the best, yeah. So in your incident response, if accounting loses a server, that's not a great day. But if a process control environment starts to have issues and you have humans inside there, that's a terrible day. And when we talk about manufacturing, it's not just manufacturing, not just water. In fact, this came up, it was a conference last week. Smart buildings. Yeah. What's the difference here? I'll ask this question. What's the difference between a smart building that has a couple hundred people inside it and a manufacturing operation with process controls that are building big things and moving around quickly? Yeah. Who wants to? So when you don't have proper prescription and you're inside a smart building in the elevator, who wants to be there during that incident, right? So smart building, and then office workers, manufacturing, shop floor workers, very similar, right? And patch management and vulnerability. I think it was a presentation going across the hall. It's all about patch management, being right and left of boom, okay? What do you do when your PLC manufacturer puts out a note and says there's no update to this vulnerability? It's an older system. It's not in the roadmap. Okay? And a lot of times and we heard one of the responses was buy a new one. A lot of times it's not economically feasible to do that. Or I have to take the plant down in order to move a component that's part of a process run. These are not things that are easily done in manufacturing or water. And these are critical systems. Electricity to an outlet, water to a faucet, raw materials in, widgets out, right? To do that scheduling, it takes time. The other thing I get asked about, we always talk about ICS threats and threat actors and the increase in sophistication. And people ask me, why aren't we getting more sophisticated in the control systems? Does anybody know the average life cycle of a control system? Yeah. So at the time the threat actor is born, the PLC goes into service. By the time the threat actor is 20, it's still in service. It's not that our systems aren't becoming better. It's that they're still working, and they are what they were when they were put in. Okay? So we have to take a look at, maintenance schedules months apart, due to equipment age, vulnerabilities exist. If you understand what the risks to those systems are, then you figure out the risk mitigation. And sometimes it's air gapping, right? Wait. Oh.
Doing that, I was going to give a kind of little story. I was working with a nuclear plant, and I had to go overseas, and I had an old Dell 830, and I had Dell Pro support, and I had a problem. And I called Dell, and they said, "We can't help you. That machine is now out of support." So they had to send me a new one. So when I got to the nuclear plant, they had an entire room full of Dell 830s that were never taken out of the box yet, before they could even be used. And these were also going to be used for setting, safety relays, you name it. This isn't, machines that were going to be used for the office environment. They hadn't even taken them out of the machine before that machine was out of support. And it's not just nuclear. You'll find this throughout industry, and also really heavily in DOD and, the government. Big organizations take a really long time to do things. And that's fine for our old stuff that wasn't susceptible to all of these new changes. And that's a real concern.
So now if we just take a look at the OT practice, thank you, Joe. If we take a look at the OT practice and we start looking at what are the positive outcomes, we'll keep our IT hat on, but we've got OT goggles, right? So we're going to look through that lens. Vital critical assets and OT systems should have significantly reduced or prohibitive access to external networks, right? And this gets back to what Joe was talking about. What is remote access? Is it third-party MSP or ESP connecting in? Is it a internal personnel connecting in from at their home? Or is it portions of a distributed control system that aren't even humans that are interacting with other systems, right? So being able to impact an activity or execute an activity from one system to another could be considered in a process control environment remote access. So you take a look at these things through a different lens. What are we trying to do? What needs to talk? Anyone who's got OT system needs to talk to the internet, open across all protocols into any external access. It needs to take a second look and figure out what the heck is going on there and why this was prescribed as the risk mitigation when it's actually increasing risk and vulnerability. Firewalls, restriction of protocols and services and applications within the environment, not the edge, right? But within the environment can have an adverse effect. Make sure you know what protocols are necessary. Do packet captures. Anybody set up span ports, right, with Wireshark? Pascal Ackerman, he has a great book written, and he has 2 or 3 chapters that are specifically on setting up mirror ports and turning on your the Wireshark and in collecting data, if nothing else, to do it passively, not against the system, doing it passively on mirror ports to collect that data. Security scans, potentially causing OT malfunction outages. We talked about that. Scans of OT assets can tip over assets, right? And asset management is key. That's the foundation. If you leave here with anything, understand that it all starts with asset management, and then your risk mitigation, your risk management, and then OT, your prescription of OT solutions is on the output. Know your patient first. And then preventing external access or internet viruses, increased knowledge of OT devices, right, as we look at passwords and password rotation. And then maintenance schedules, rotation cycles, collaboration of IT and OT personnel. Also know your collaborators on the other side, right? And who are those folks in the ops and the engineering groups? Build those bridges. They can be squirrely and they can be finicky. Okay? I'm sorry, I'm just teasing. But have to be able to have that common vernacular, that common communication. And that starts, as Joe was talking about, starts with getting them to the table and getting them to talk about what it is they have and what are the assets. They are the process and the asset owners. And then back to basics. If anyone's been to any of my other presentations, it's always the basics. So I usually start off, some folks have said it's like a primer, again, OT for IT folks. But it works in process control environments as well, for those process owners and those engineers to get back to basics. Know your assets. What are their dependencies and characteristics? Understand the processes involved. Complex IT-centric defenses can increase your OT risk, not reduce it, okay? And in collaborative processes, both OT and IT personnel, control systems, as we said before, can be allergic to the IT penicillin. The alliteration is terrible, I know. I was trying to keep it interesting. And then most of all, and then it was when Joe and I were working this up, it was the KISS principle, right? So keep it simple, every time. We actually have, so you have probably two of the most verbose speakers on these subjects up here. We actually got in under time. So I'm going to open this up to questions. Yes, sir. ISA 62443?
You had a different perspective. For 12 years, I was a managing director of it. Okay? Our session here, in 2001 is what precipitated the development or the establishment of ISA 99. Is it a good standard? It is a very good standard. However, part of the reason I'm on ISA 8409 is it doesn't address the level 01 devices. If you look at 4.2, 4.2 is the procurement spec. I'm going to give you a real story. This was about 2 years ago. An engineer in Abu Dhabi wrote a LinkedIn report. He was installing 3,000 brand new transmitters on a oil gas refinery plant in Abu Dhabi. And he needed to, after they did the calibration, send the data up to the big cloud in the sky. So we went to his vendor's spec to get the passwords. There were no passwords. I had the discussion all the way to the top of our government. Legacy devices do not meet the requirements in 62443, which is why 8409 picked this up under safety, because the out was, the same way NIST out is, if you can't do it, use compensating controls. Only there was never any mention as to what the compensating controls were. 62443, unfortunately, when we first started, it was all engineers. It is now very, very heavily oriented toward OT network people, not engineers. So what you find in the 62443s is an awful lot of quote-unquote network-centric focus. Has the word OT in front, but where this was supposed to have been from day one was addressing the things that weren't being addressed elsewhere, which were the sensors, actuators, drives, the engineering devices. That's hard. We ended up doing an 8409 because it had to be there for process safety. Theoretically, that should have been done in 62443.
Any other? It's a great question, by the way, and you, perfect time to ask it. Do you have a question?
I do.
Yeah.
Hello. As we continue to bring manufacturing back to the U.S., specifically in microchips and manufacturing, all of that. So have you seen any plans on how the U.S. Continues to educate people on OT, especially the younger individuals who are coming out of college or tech schools? Because I know a lot of OT is very much tribal knowledge or seasoned individuals who've been around it for so long. Have you seen any kind of plan to just educate the masses more on OT?
So it's interesting, we were just talking about ISA 62443, and Joe was talking to the working group. So I'm just trying to be track of time here. Yeah. So I am attached to and work in conjunction with ISA Working Group 15, which is workforce development. So we were looking for ways to engage, whether it's professionals, students, schools, it really doesn't matter. They have the, the Center of Excellence or whatever
Yeah.
With INL. But really what it gets down to, and I don't want to go down too much of a rabbit hole, but there are, so we're talking about education, so there are initiatives. I'm also adjunct professor teaching at 2 universities in Minnesota. I'm originally from Twin Cities in Minnesota, so Minneapolis, St. Paul. I teach classes there. The interesting thing is I teach a class of the cybersecurity folks on OT systems, and I teach cybersecurity to the process and control and mechatronics students. So I'm trying to build that, right? But, and I know Joe is, man, it was years ago I was watching a video, you were at Sanford. So we have indirectly, or I should, that's an incorrect word, but we've begun that process. I think it's going to take a lot, but there are universities and colleges that are now adding this in. I've seen it in the master's level, okay? Certainly at the doctorate levels, because it's important, and it's starting to work its way into the curriculum at the undergrad level. And what we would hope is, who went to, so you probably have to be older, I'm 52. Who had an industrial arts class in high school, right? Where did those go, you know? And we have the trades as well. So, but we're starting to see that sea change where it's coming on. That is an excellent question. It's something near and dear to my heart. Is there any type of a consistent effort? I think we see with CISA, and we see with, with organizations, worldwide organizations such as ISA with a push, INL with the national labs, they're doing a lot in that space, but there is a push towards that.
The one gap that still exists, and then I'll turn it over, is all the way down at the lowest level. In other words, the sensors and the actuators. There's still very, very little being taught there. Generally, that's taught in the non-security world. You have all kinds of courses that you would take on, PLCs, sensors, calibration, da-da-da-da. But there's no cyber to it. Where you get the cyber, what they do is basically assume the sensors and actuators are fine, and the cyber is working its way up. I just had comments back to Idaho State and others on what they were doing, because this is what's missing. And this is where, quote unquote, you go boom in the night, or where you can't meet EPA requirements, or you can't meet other things. The flip side, let me just leave it at this. Sensors are unique in the sense that they are the underpinning of everything. So that's safety, reliability, performance, as well as cyber. So when you talk about doing things at the sensor level, you actually pick up all of that, because this is your fingers, eyes, ears, nose. This is what's going to the CPU. The brain simply assumes if the finger tells you something is hot, it must be hot. Or think about being colorblind. If it's telling you it's blue but it's really red, unless it's a traffic light where you could tell, where it is in order, particularly if it's just a single flashing light and you have to be colorblind in that area, the brain isn't going to decipher if the eyes can't tell you. Do you follow where I'm coming from?
Just so I get this out of the way, and I know we got like a minute left. If anybody wants this deck, and I know it's like 4 to 6 weeks as an attendee to get it, if you connect with me on LinkedIn in that very, very small Sanskrit that I've got up there, but if you get that and connect with me on LinkedIn, I'll send you the PDF. Yes, sir.
Okay. Just really quickly, other than 62443, if you're building out a brand new OT network, what other standards should you look at? I guess that would be my primary question.
So I would say it's, well, ISA 99 actually got NIST out of the gate on 882. So you could start with 882. I would say because there are IT systems in the OT environment, Windows Engineering Workstations, Windows Linux, HMIs, or SCADA systems like inductive automation, factory talk. So NIST CSF is a good place to start. But keep in mind, ISA 62443 is a horizontal standard. It can be applied to your IT systems as well. Joe?
Yeah, the only thing I was going to say, if you're looking strictly at the networks, I would do two things. Number one, look at the IT things because they're generally applicable. But one of the things that happens is people have a tendency to try to apply these IT standards without understanding the implications. And I'll give you just one example. Almost everything you go to where it talks about networks is what happens if somebody tries to get in using a bad password. After X number of times, you lock them out, right? If you have a critical workstation, the simplest way to hack or cause a major problem is to put in the wrong password. You can't just, blindly apply network technology to systems that could have physical effects. And there is a tendency to want to do that. It's an internet protocol network. How can it be different? There's a huge amount. We started 99 to address the unique stuff that the 27,000s didn't. So it's not to say don't do one or the other. If you're going to go beyond networks into my world, there's more to do. If you're going to be just at the networks, there's lots and lots of good things out there. The biggest thing is to have people who are smart enough to know and tell you, are there unintended consequences, which is what this whole thing was about, that can occur if you're just effectively blindly applying, this technology in an environment that maybe it shouldn't be blindly applied. Does that help?
We're
Yep, we're out of time.
Yep,
Paul?
out of time.
Paul, Joe, thank you very much.